So my talk is going to be about large language models and generative AI. And first, I'm going to introduce myself a bit. I'm an artificial intelligence engineer working at IAG. And a few notes about myself is that I studied audiovisual systems engineering that is very similar to telecom. And then I did a master's degree in artificial intelligence. Between the master's degree and my university years, I was working for a hospital doing disease detection in kidneys, and that's why he mentioned that about myself. And that's where I fell in love with the computer vision stuff. And then I started working on a startup that we did mostly object tracking and object detection. That was my talk about last year, was about urban analysis using object detection. And now I'm mostly working with large language models and generative AI. So today my talk is going to be about a RAG model. So the way that I structure this talk is that first I'm going to do like a brief theory, and then we'll do like hands-on implementation of a RAG model. So brief theory about large language models, but that I believe all of you kind of know more or less what they are. Large language models are a type of deep, artificial intelligence that are deep learning models that use deep neural networks, and more precisely, they use a type of architecture that is a transformer architecture. They are trained with vast amounts of data, and that's why they are able to understand, generate, and manipulate the human language. And that's why we find it so useful, and all of you have used probably ChatGPT. And then what is RAG? RAG is Retrieval Augmented Generation, and is an innovative approach, more or less, I think it came up at 2020. And basically what it does is that it combines large language models with a retrieval mechanism. So to put an example for you to understand, so imagine that you are a lawyer. So for instance, my father is a lawyer in Barcelona. He would like to use ChatGPT, but he doesn't know which data set it was trained on. He doesn't know if the laws that are indexed in that model, they are updated, if they are the ones that he needs, or what's the situation. So he can use ChatGPT, but he will always need to double check this data. If you have a RAG model, you can train the model with your documents, and it will be able to just answer based on these documents that you have feed the model. So for instance, you can feed the model with like all the laws of Spain, so I don't know, 1,000 pages document. And you can ask it to only answer based on that. So you're sure that your answers are correctly. So in this way, you increase the accuracy and you reduce the hallucinations of the models. So here, I'm going to explain the architecture of these models, and this is exactly what I follow when I did the code. So there is like two parts of it. There is the retrieval part, that is how it chooses which side of the document is the one that is related to your question, and there is the other side that is how it generates the question so that a human like us can understand it. So first of all, you can see, okay, I'm gonna maybe go closer. We'll start with this part of here. So first of all, you have your documents. You need to extract the text from your document, so from PDF to text. Then you need to divide this text into smaller sizes. This is chunking. And then we need to convert the letters of the text to numbers, because models understand numbers. And then you will save all of this in a vector database. This will be the part of retrieval. So when I ask a question, my model, that is RAG, is gonna, from my question, convert it to numbers, and then it will check if those numbers are similar to the ones in the vector database. And then to generate the answer, what it will do is that it will take the most similar documents, so for instance, top 5. Then it will create this ranking that it will fit the large language model. So the large language model will have the context, that is the documents that you have, well, the best documents, and then it will have the questions. And with this context, it will be able to generate for you your answer. So now I'm going to show you the hands-on implementation. This is the repository that I did in case you want to check it. And okay, let's go. Just brief mention about the requirements. I use LangChain, that is the library that is basically how you use large language models with Python. I use Quadrant for the vector database. I use Python for the language. And then I use Grok, that is the way for me to be able to call the API for the large language model. Okay, so step one of the code is to prepare the documents. First step, and it's very obvious, but it's like from PDF to text. I created a very simple function that you can see here that basically is reading the PDF files and then extracting the text from it, and then I return the text. Then the next step is to split this text. You may ask why. We need to split the text because large language models have a limited amount of tokens that you could you can add in each of the steps, like in each iteration. So you need to chunk the documents. And there's a lot of techniques to do this. There is like basic chunking, so you go and split. Maybe you can split a document by pages. It's more interesting if you do it in a way that it makes sense, because the way that you will split your document is the way that your large language model is going to have the context. So for instance, I use recursive character splitter that basically is looking for the most optimal point to split the text. So for instance, when it's the end of the paragraph or when there is the end of the sentence. But if this is like it's bigger than the size that I have marked as a chunk size, it will iterate over the text and find the next best spot. There's a lot of techniques to it. What I have found is that for sure it's better when you use some overlap. So between one chunk and the other is not the next phrase, but it has a bit of both. So the model has more context. And there is also other ways. For instance, you can create a summary of the whole text, so like of the 1,000 documents, and you can put this summary in each of the chunks. In this way, the model always has the full context and is able to understand what is the bit piece that it's feeding at the moment. But this is different techniques. In this case, I used the simpler one. So I did the recursive character splitter, and I just put the chunk size and a bit of overlap between each of the chunks. And then you basically split the text and save it into an array. The next step is to create the embeddings. So as I said before, the models, they don't directly fit from text, but they fit from numbers. So what you will do is that you will convert your words, phrases, or paragraphs to a vector. For instance, so this vector, what we'll do is that they are based on the meaning of the word and not based on the of the letters of the word. So for instance, queen and king will be very close together in a vector space that is representing the whole words of the English language. And this in code is very easy. You just call a model that in this case it's it's a simple model. It's relatively small. It's only trained in English language, but it's enough to create the embeddings. And you will just call these functions and create the embeddings for all of the chunks that you have just created previously. And then for the next step, now you have all the chunks of the documents and you have all the embeddings. You need to save all of these into a vector database. And the vector database is a database that is prepared for vectors. And it will enable you to do similarity checks between the vectors. So when you ask the question and you want to find this question, it's similar to which piece of my text, you will have two vectors. And with this database, you will probably compute like similarity, cosine similarity, most probably. And you will see how far away these embeddings are. There's a lot of course, this is the most simple one. If you do cosine similarity, you can do more complex similarity checks. For instance, you can train a machine learning model to see which is the best ranking based on the whole context of the text. You can do the ranking based on the whole conversation of your large language model. So if you have been asking questions to it, you can keep this history, and then when you do the ranking, take into account the whole context of it. So there is a lot of techniques here. This one is the most simple one. So you just measure the difference between one vector and the other. And here you just have the query, that is the question of the user. And here is the similarity search function that I was mentioning, that in this case is cosine similarity. So all of this will be building the side, the part of the retrieval of the model. And now we will go to the part of the generation of the question. So here, so now it's when we will use the large language model. So in this case, first you will need to create a nice prompt. This is not very huge, but it works sufficiently good. So basically what I'm saying in the model is that if you just answer based on the document that you have, you will have a context and a question. And if you don't have this information, just say that you don't have this information. But this is to decrease the hallucination of it. And then what we do, that basically we call the model. In this case, I'm using Llama 3. It's pretty good. And then I am combining the context that we have with the query that we have, and I'm feeding this to the large language model. So it has the context, it has the query, and then it's generating an answer that is in human language so that we can understand it. So that's the theory. Well, that's the implementation of the code. I want to do now the demo so that you can see how it works, and let's hope it works. So here is the demonstration. I did a bit of a front end just to make it prettier. Okay. So here, let's see if it works. What I did, let me first show you. I created these documents that are super easy. I created them with ChatGPT. And they are like very brief data, so it's easy to do a test and to check if the data is correct or not. And so here you have different things. And so in here, what you have here, you can see the topics that you can ask the model. And I have here predefined some questions so that I don't need to write them now. So let's do like, what is the significance of umami in traditional Japanese cooking and how is this typically achieved, okay? So here, okay, that's the question, it goes pretty fast. And then here is the answer. I don't know how comfortable are you with this topic. I tried this several times and I don't know that the answer is correct. And now if I do if I ask something that is not in the dataset, so for instance, what are the main ingredients of pierogies? I think it's a typical food here. Now, if it answers, it will make me look very bad. I don't know. The provided information is about Japanese cuisine, and it does not mention pierogies on their ingredients. And then it's putting additional information here because I put it in the prompt that it can provide additional information. But as you can see, it's pretty accurate. The responses, of course, I'm using pretty easy documents that are not hard to follow. But that will be the main point of the implementation. And I think it's very useful in several places. In our case, in IAG, we implemented it to have like a ChatGPT internally in our company. So in the procurement department that is huge in our company, we created this model and we had several challenges. One of them was that there were thousands of documents and it's very hard to do all the ingestion process because it's lots of documents, they are not very structured, there is images on the documents. So we needed to tackle that. So we were using multiple AI algorithms. So for instance, if we have a diagram, we needed to call one, just understand the diagram, and then other things. We needed to add a multiprocessing layer to process all the documents. We had all the security checks that we needed to do because data is private. So because in our case, here I'm using Llama, that is open source. In that company, we were using OpenAI's API, so ChatGPT, I think 4, and then we tried 4.0 and 3.5. Most of them were kind of similar answers. And that's it. And I think, well, I wanted to present this project because I think it's really easy to implement. So as you can see, I explained that in like 17 minutes. It's easy to follow, and it was the first project that I did with large language models that I felt that it was really interesting. And okay, I think that's it. So thank you all. And if you have any questions, please.
Any questions from anyone? Back there, 2 questions.
How big are those vectors? How many dimensions do they have?
What?
How many dimensions do those vectors have after embedding?
So actually, I don't know. I think, but it's not too many dimensions. I think you can, so depending on the model that you are using, it will have one or the other, but it's not like a huge array of like, I don't know, like 1,000. No, it's like pretty simple. But it depends on the model that you're using. Because for instance, if you're doing a data set that is the whole English language, it will be one thing. If you want to be very specific and you have only one thematic, maybe it's like a smaller. So like only, I don't know, words about animals. You don't need so many dimensions. So I think you can kind of change it.
Thanks, nice talk. I'd like to ask if there are any techniques for making sure that for validating the correctness of the answer, because if I was a lawyer, I'm not sure if I would trust ChatGPT on anything, basically. But maybe we can somehow validate the answer as well and use some other techniques for that. Are you aware of any?
Yes, so actually it was a huge part of the project. So how do we validate that this data is correct? First of all, inside the company, what we did is that we had exactly like this chat, but once you have the answer, you could also see the PDF file where it is extracting the data. So the page where it gets the data. So the person that is using it actually can check like, okay, it's giving me this information and I can read here that this is correct. There is no so there is several ways that you can evaluate these models. None of them were very useful because it was with data that is internal of the company. So how do you know this is true or not? There is techniques where you can use different large language models to evaluate a large language model. So you create a combination of them, and then you ask this question to several of them, and the others evaluate. We tried this, is pretty fun. But also we were not in a point that we were sure that it worked. So at the end it was okay, we show the document, and if the answer is matching with the text, then it's supposed to work. If not, so it was not so accurate. But yeah, that was a very big part of this project, actually. Yes? Oh, I don't know.
I think Chad has a question over here in the first row. Mike is coming. Oh, Mate first. I'm sorry.
I will hear you.
We'll get you, Mike.
So shall I start?
You have a mic?
Okay. So are you planning to do the same experiment with few-shot learning because the context size of these models are getting larger and larger, so it becomes possible to give all the documents to it and give a few examples, and you could run the same experiment on that and comparing to RAG. So what's your opinion on that?
Wait, can you repeat? Because I think...
So are you considering to do the same experiment instead of RAG, to do this few-shot learning approach?
Oh, okay. Actually, this project ended some months ago because it was already in a point that it was good enough, so we didn't work more on it. But I think actually it will be really interesting to try in a few months and see how it's actually worth it to do it all of this process, or we can just implement it. Yeah. But we didn't try it, so I don't know.
Thanks.
Maybe a somewhat similar question. Do you? I've used LangChain for piping different responses together.
Okay.
Do you really even need LangChain in this use case?
No, actually, I use it for this demonstration in our company. We didn't even use it.
Okay.
So this is just a little project that I did for this presentation because I didn't want to change the other one so much because data is
Okay, that makes sense.
Yeah. So here it's an easy version. Yes.
Thanks.
Okay, I think.
There is another question in the back.
Thanks for the talk. Did you ever try to integrate your own LLMs instead of relying on external services?
Actually, no. It's something that I wanted to try, but it's I don't know. You need your time and the computational power, so I have never tried. But it will be really interesting.
Thank you.
Anyone else? All right. Thank you very much, Paula.
Thank you.